Alrighty, so the layers of the earth. Yay, so exciting. Okay, so this is what our earth kind of looks like. Of course, we live about right here near Atlanta. We have the crust, the mantle, the outer core, and the inner core. So that is what we're going to be learning about today. So did you know the deepest hole ever drilled was in Russia, and it was about 12 kilometers deep. So that's I want to say about 15 to 16 miles deep, which is extremely deep. Mount Everest is about 9 kilometers high, so we drilled further than how tall Mount Everest is, which is really kind of cool. So if we've only drilled into the crust, how do we know about the mantle and the core? Very good question. It is because of these waves that we call surface waves and body waves. Geologists use seismic waves, which we can use from earthquakes, to study volcanoes and things like that. So what happens is that when these waves kind of come through, we can time it and see if it bounces off something else and see how long it takes for it to come back. So we can tell by where it hits and how it hits and how long it takes to come back, that we can tell that there's something else inside of the earth that we might not have previously thought was there. So how seismic waves move through the earth. So an earthquake happens and you expect it to, kind of come straight through the earth and then we can feel it on the other side of the earth. Well, that doesn't happen like that. So if it hits something else, it's going to deflect off of it and kind of go a different path. And if we follow that path, we can see that there's more dense things there that'll cause it to go in a different direction. So if there was nothing in there, it would go straight through. But because there's different things in there, different densities, different materials and things like that, we can tell because of that deflection or that different way that the wave is carrying and the time that it takes for us to read it and things like that. So temperature and pressure increases as you go into the earth. So keep that in mind. So as we go deeper and deeper, if I can go back, if we go deeper and deeper inside the earth, that pressure and that temperature is going to increase. So it's going to get hotter and your ears are going to pop, and your ears are going to pop like when you get like right here. Even if you go in Ruby Falls and things like that, where you go deep underground, it's actually not that deep. You're still in the crust. Which is still like right in here. So imagine if you go, down here or down here or down here. Of course, you wouldn't be alive anyway, but if you did, your ears would really pop, and you would probably not be here. There are 4 layers, so we previously talked about this on the first slide. The first one is crust. This is the thinnest layer. The mantle, the outer core, and the inner core. So make sure you know all 4 of those. Very, very simple for you to know. The crust, the mantle, outer core, inner core. All right, the crust. This is where we live. This is the outer skin of the earth. This is the thinnest layer, and it's actually thinnest under the ocean because the ocean, is water, and then underneath that is a very, very thin layer of the crust. The thickest is under mountains because we have to account for where the mountain starts, which is above where we live, and then all the way down to underneath the ocean. So that's about 100 kilometers thick, whereas under the ocean it's only about 5 kilometers thick. Its temperature can range from 0 to 1,000 degrees Celsius. So make sure you have that down as well. This is less than 1% of the Earth's mass. So where everybody lives is 1% of the Earth, which is really kind of weird to think about. There are 2 types of crust. So on the layer that we live, the first one is the oceanic basalt. This is the denser part of the crust. So it's going to kind of go down. It's going to be heavier for us to deal with. And then the second one is the continental granite. And we know granite is an igneous rock, and so is basalt. So think about, maybe how the crust was originally formed. So maybe volcanoes were involved. But the oceanic basalt is denser than the continental granite. So this is where we live, up on these mountains and things like that. We've got the ocean over here. And our continental crust is this part right here, that yellow part. And then our oceanic crust is underneath the ocean. And this is going to be denser right here. This is going to be not as dense. We can get through this a lot easier than right here. And then right underneath here would be the mantle. So what happens a lot of the times with plates moving and things like that, the oceanic crust is more dense, so it's actually going to go underneath the continental crust. Now when this happens, it's called subduction, and when subduction happens, volcanoes occur over here, which is very interesting. So the continental crust will move, it's lighter, so it's going to stay on top, and that oceanic crust is more dense, so it's going to come down underneath the continental crust. So make sure you understand what's going on there. The next layer is the mantle. This is the hot bendable rock. It's about 3,000 kilometers thick. It is actually the thickest layer that we have. It makes up most of the Earth's mass. It's about 67%, or you could, round it up to about 70%. It's more dense than the crust because it has more magnesium in it. More magnesium. And it can range to be 1,000 to 3,700 degrees Celsius. So it's getting hotter, a lot hotter. The very top of the mantle is solid. That's, right underneath the crust, but everything else is pretty bendable rock. So that rock starts to heat up very, very hot. So it'll start to kind of not exactly melt, but bend, kind of like our metamorphic rocks. So it'll move, and it'll cause things to on top of it to move, which is why we have plates and things like that. So it's important for you to know that the mantle is kind of, I want to say like a jelly or a jello that kind of moves a little bit, but it's not completely melted. The inner layer, which is the core, and the core is, broken down into two different layers. It's a little smaller than the moon, so if you want to think about it, we do have kind of a moon-looking thing inside of the Earth. It's made of mostly iron and some nickel, which are very, very dense metals. It's about 10 to 15% of the Earth's volume. It's about 30% of the Earth's mass. And we've got two parts to the core. The first one is the outer core. This is the thick liquid metal because it's so hot that it is actually liquid. It can range to 3,700 degrees Celsius to 5,000 degrees Celsius, so very, very hot. Its thickness is 2,250 kilometers. And the inner core is actually solid because of all the pressure. Now, it is hotter, and you would think that maybe, okay, it's hotter, it's definitely going to be liquid. It's not because of that pressure. And we'll look at this in class to kind of, remember that the inner core is solid, but make sure that you highlight it, put a blinky sign next to it, that the inner core is solid, okay? The outer core is liquid, the inner core is solid. That is a big difference. Its radius is only about 1,200 kilometers, so this is very thin. It's not as thin as the crust, but it is pretty small. So some questions for you. List layers in order of density and temperature from lowest to highest. You got the crust, the mantle, then the core. List the layers in order of size. The crust is the thinnest, then the inner core is the second thinnest, the outer core, and then the mantle is the thickest. Which layer can support life? We know this, it's the crust. Just things for you to kind of think about. If you drove a car 100 kilometers per hour, 62 miles per hour from the Earth's surface to the center of the Earth, it would take you only a half an hour to drive through the continental crust, 29 hours to drive through the mantle, about 35 hours to drive through the core, which is really weird. The mantle makes up about 80% of the Earth's total volume. Pressure at the center may be 1 million times greater than the air pressure at sea level. So when your ears pop and things like that, try and imagine that to be 1 million times greater. Density compares to water. I don't know why I put that on there. The crust is 2.5 to 3.5 times more dense. The mantle is 3.3 to 5.5 more dense. And the core is about 10 to 13 times more dense. Oh, I'm sorry, than water. Yes, that's why I put that on there. Hello, Miss Dubek. Okay. All right, make sure you have your notes filled out, and then next time we will talk about what does this have to do with plate tectonics.